Thank you for joining me. Today I plan to talk on deploying CMAF in 2019. Quick introduction, my name is John Gainfort. I work for RealEyes Media. We're an advanced video solutions shop located in Denver, Colorado. I've been doing video streaming now for 5 or 6 years, and I do it for some major events with some major companies. This is the outline for the talk. Plan to start off, discussing what is CMAF, what are some of its features, some advanced considerations that you should take into account when you decide to make this switch, and what's the future of CMAF, and then finally my own conclusions at the end. So to start off, what is CMAF? CMAF specifies a container. Okay, I want to really stress that. This has nothing to do with the manifest. It's literally just your segment containers. Okay, so it is an ISO BMFF FFmpeg container. It utilizes common encryption. Baseline supports HEVC, AVC, AAC, and interoperability with VP9, AV1, you name it, right? It still utilizes the same captioning that you use today. So WebVTT, 608, 708 captions, all of that. Okay, doesn't change. The one big difference I would say that this has is it requires non-muxed audio and video fragments. So you have to have 2 separate fragments. You need your video and your audio for this. It is required. And I like to highlight that because that kind of bit us early this year. We didn't really realize that, and then now we had to go back and rework a bunch of our stuff because of that one particular feature. So quick translation on what I mean by some of this stuff. So it specifies containers, so it means this has nothing to do with HLS or Dash, okay? It is strictly just, like I said, on your segments, okay? And because of that, the same segments will work in HLS or Dash, so you don't have to switch up. If you're already using Dash, you can keep using Dash. If you're using HLS, keep using HLS. It doesn't matter. It utilizes common encryption. That's for DRM, very complicated subject, and we do apologize for that. Then codecs, they don't matter, okay? You can use whatever codec you want. That's up to you. Like I said, same old CC subtitle options, and that lasts a little bit. Like I said, pay attention to that. Don't let that bite you later. All right, so one of the key features of CMAF is it can increase your performance, okay? So because you can utilize CMAF, you don't need to do client-side transmuxing of your HLS TS segments into MP4 to feed through into your media source extensions. So because of that, you get a nice little bump in performance on that. You can directly pipe your CMAF, your fragmented segments, into your MSC, and this was going to work on your browsers, on your WebView devices, anything, any of the smart TVs, limited hardware devices, and anywhere that HLS isn't natively supported, essentially. So again, what are the key features? What this allows for unified segments across your different manifests, and it offers some improvements with DRM. So first, let's talk about some unified segments. So before, when you were encoding and packaging your content, you had a package for both HLS and Dash. HLS was using MPEG-2 TS container formats. Dash was using its own MP4 format. So you would have to have 2 separate segments and then store both of those segments at the same time. And then now, with CMAF, you can have the same segment packaged for both HLS and Dash. You only have to store 1 segment instead of 2. And then what this means is you no longer, let's say some companies were utilizing both HLS and Dash players. Well, now you can keep for doing that. Or you can make a switch to 1 and be unified across sub. So with unified segments, it lowers your production costs associated with encoding, packaging, and storage. So that's a big key benefit. It can significantly improve your CD and cache efficiency, especially for live video streaming. Adds a foundation to find additional conformance points for content and devices regardless of manifest protocol. And most importantly, what I like most about this is it provides common ground for industry cooperation. Okay, so that is just a really big key feature in my opinion. I just want to make a quick important note. If you are using HLS, you need to specify version 6 and above. Some players like ExoPlayer, HLS.js, Bitmovin, they probably won't care about this version, but then if you plan to use Safari, AV Player, so anything Apple, they are very strict and they do require that this version be set. Moving on to some DRM. So what CMAF offers with DRM is cross-platform and media format capability or compatibility. So right now, CMAF will be supported out of the box by AV Player, ExoPlayer, and Safari. What it allows is for single encoding and encryption, okay? And this is because of common encryption, right? And with CMAF, as mentioned before, we do not require transmuxing on the client side, okay? So what we can do now with CMAF is a single packaging workflow for the most part when it comes to DRM and single pat publishing. So some quick terminology. I'm going to stay to the two highlighted ones. We have common encryption, AES-CTR, or I'm going to refer to as CENC, and we have CENC at the bottom, AES-CBC pattern, or CBCS. So what the big challenge is CBCS compatibility. CBCS is being utilized by Apple, so that Apple FairPlay, and all major browsers are moving forward to supporting CBCS. Widevine CBCS right now is not working in Firefox. However, this is coming in the near future. It is working in Safari, it's working in Chrome, and a few other major browsers. But CBCS is also not supported in Edge. However, that's going to be changing with their introduction of their new Chromium-based browser that is currently in beta right now. We're expecting that to be released in the next year. As mentioned earlier, CMAF does not allow mixed audio. So what that means is both audio and video renditions could need to be decrypted and possibly have different decryption keys for both audio and video. So you can beef up some of your decryption DRM capabilities. One major challenge, again, is open source player availability is somewhat limited. Shaka Player does not support PlayReady and FairPlay currently. HLS.js doesn't currently support any DRM. However, us, for example, we have an open PR with HLS.js to include Widevine into their platform. But both of these platforms do have other people doing ongoing efforts to support this. So what are the options right now? One thing we're pushing for is having 2 manifests with 2 fragment encryptions for Widevine. Okay, so targeting CBCS so we can support Apple, Android, Roku, Chrome, and Safari, but then using CTR or CENC is what I said I would refer to it earlier as, to support Firefox and Edge, with the goal of moving towards CBCS as more browsers adopt to it. One key note is if you are using Android, if you need to target older Android devices, you would need to stick with the CENC, just because CBCS wasn't introduced until 7.0. An option that you also have is you can enroll your own DRM workflow for your player using EME or encrypted media extensions. So EME was designed to enable the same app and encrypted files to be used in any browser, regardless of the underlying protection scheme. So you can encrypt once and then decrypt in any browser using any of those schemes that you need to use. So for Safari, you can use FairPlay, Edge, PlayReady, Chrome, and Firefox using Widevine. But one good feature of this is you're able to contribute now back to the community since we're using common what's that word? Because we're using common formats. So here's just a quick support matrix. So CBCS is supported across the board between FairPlay, PlayReady, and Widevine. However, with Edge, we have to wait until their new Chromium-based browser comes out. And for Firefox, it's supported right about now, but I couldn't tell you exactly which version started to support it. for CNC. Apple devices, so your iOS, your tvOS, will not support CTR, and Safari browsers will not support it either. As for some advanced considerations, one big thing to keep in mind is your mixed content and dynamic ad insertion. So one big reminder, I want to bring this up, is CMAF requires non-mixed audio. So if you're doing some dynamic ad insertion or mixed content, you got to make sure that your ads, for instance, have non-mixed audio as well. Okay, so when you're doing client-side or server-side ad insertion, you need to rewrite both your audio and video manifests. One big key note is that if you are stitching your ads, you can still utilize MPEG-2 TS when you're using HLS. However, we do suggest using discontinuities for those. And that is the big thing to keep in mind for this. All right, so future of CMAF. This is one of my most, I would say, this is upcoming technology that I'm most intrigued about, low latency streaming. All right, so first to start off, what is low latency? So this quick little slide is going to demonstrate what we mean by this. So if we look at this top business use cases, sub-second latency was best used for, let's say, voice. Okay, ultra low latency range, something between 2 and 4 seconds, great for live auctions, gambling, and in this low latency range is a good range for live sports and esports. All right, so typical broadcast. So if you're watching cable at home, you're looking at a latency of around 6 seconds. With social media starting to move to the 4 to 1 second range. And if we look at today, how it's done is we're using a segment-based approach. So a standard 6-second fragment size, which is what Apple suggests at these days, you're looking at right around roughly 20 to 30 seconds of latency. By reducing your segment size, you could potentially bring down the latency. However, you're going to run risks of rebuffering. And then now with CMAF, one thing it's going to introduce is chunked transferring. And with chunk transferring, we can bring ourselves down to that 6 second even less. And then obviously a RebRTC can bring you below that sub 1 second. So this is what we're going to be targeting with low latency, is this 6 to 1 second range. So today, how the latency is derived is we have our content coming in, and we're going to generate a content. And for a 6-second segment, we have to encode, generate this entire segment over 6 seconds. We then need to upload that segment to our origin. If that's successful, we then update our manifests. If those are successful, then we're going to propagate that to our CDN or to our edges, deliver that to our client. And by default, we're going to try to buffer 3 seconds of segments. That is an Apple standard before we even begin playback. So at 6 seconds, we're looking at a minimum of 18 seconds of latency just before a user can play this back. Now, to combat that, we can do 2 things. We can do chunked encoding or chunked transfer encoding. So chunked encoding is how it's going to be made. Chunked transferring is how it's delivered. So how the encoder breaks down and saves the data is chunked encoding, and then chunked transfer, how the data is sent and made available without knowing a final size. So using HTTP 1x1, we can stream our content now through our entire system. So we encode our CMAF segment using chunked encoded content, or CMAF segment content is chunked encoded. We update our manifest before it's fully created. We can push this up through to our origin and through our CDN using HTTP 1.1. We can distribute that now through the rest of our CDN tiers using HTTP 1.1, and then the player can now request our content using a fetch first an XHR API to then read and download those segments as they come in. So what you see is, a player, when it's at live edge receiving chunk transfer encoded, it's still going to take the same 6 seconds to download this segment size. But what the big benefit is going to be is if somebody's going to be behind your live point. So let's say 18 seconds, you're going to see a massive decrease in how long it takes for your client to download those same segments. So chunked encoding transfer is based on HTTP 1.1. This technology has been around for 21 years. So your CDNs today will be able to support this for the most part. You're going to be able to utilize their same existing caching systems to achieve your scale. And this is proven technology that already is out there supporting millions of users. So as a conclusion, what does CMAF offer today? It offers you to have unified segments. You no longer need to supply MPEG-2 TS and MP4 for your dash content, so it's saving you on your CDN costs. Unifies DRM for the most part. You no longer need to have 3 separate manifests for fair play, play ready, and widevine, or the different encryption schemes. Now we're boiling that down to about 2. You're going to have an increased performance on the clients as you no longer have to do client-side transmuxing of MPEG-2 TS into your MP4s. And then it's going to set you up for low latency when it's ready. Some of the pros of CMAF, as I've mentioned, is this unified content is really good. Utilize your CDN, utilize their caching abilities. You have better performance for MSE implementations, as I mentioned. No longer have to do the client-side transmuxing. Scalable low latency is capable, utilizing industry standards. So you no longer have to do custom integrations. And then DRM unification to CBCS is very realistic in the next 9 to 36 months. And we say that's a solid guess. Right now, Firefox and Edge are our limitations, but those are coming really quickly. A couple cons is, as I mentioned, is this external audio can cause some challenges for you. You do have to make adjustments to your current client-side or server-side ad insertion strategies. And some legacy platforms may not be able to support this. So a quick little roadmap is basic CMAF delivery. Get your encoders or packagers to output basic CMAF segments and manifests. Okay? If they do that now, your players will still play back without any changes. Then start integrating multi-DRM delivery, so CBCS and CTR, and following by low latency encoder updates if you need to do them. Validating the CDN chunk transfer delivery, so uploading to your origin, propagating that throughout to your CDNs using chunk transfer, and then finally updating your players for support to low latency. Some changes that need to be done are example of doing fetch requests instead of HTTP GET, so utilizing HTTP 1.1, and then it's how to present the segments to your player utilizing something like LHLS or something like that. So there's some quick resources, and I have provided a quick little link at the end. So it's bit.ly/re-SME 2019. If you go to that, you can maybe provide us some any feedback or get these resources for today's topic or any of our other presentations that we've done today regarding multi-CDN or machine learning. And that's it. I have some time for questions, if anybody has any. Yes?
I just want to make sure, because it wasn't clear. Does it require non-lux audio or no, I'm joking. Thank you. Okay. How come, what is that limitation? What's the reason for that? Is that to move to?
Why are they requiring non-lux audio?
Yeah.
So the non-lux audio is really setting you up for multi-language. So it's a great thing to actually introduce. So instead of having a single audio in your video track, now since you can have that external, you can set yourself up for English, Spanish, French, German, whatever you need. And therefore your players will be able to adapt to that very easily.
I guess we're mostly AVOD, so I guess that's a major challenge for the AI brands. Not having control of the ad creative that's coming in.
Yes.
It sounded like your interim solution was two full sets of data, just kind of like where we are now with HLS and Dash. It's just CDC and CTC. So did I read that right?
Yes, that is a current limitation. However, we think that's going to be a change in the next few months.
So what's the argument for doing it now instead of waiting until that's a reality?
So it'd just be setting yourself up now. That's all it is. And not everyone necessarily does DRM. So if DRM is a complication and you don't want to have to supply two different manifests, then that is a consideration to wait.
Well, talk about you're not doing DRM. What's the current solution to that?
For non-DRM,
Yeah.
what's the major switch? Because so, as I've mentioned, you get performance boosts due to client side.
Can you use CMAF today if you're not?
Absolutely. So absolutely, you can do this today. Almost all encoders, packagers, CDNs will be able to support you right now. All players will be able to support this right now.
What's the? I'm sorry for dominating this, but what's your source for the 95% compatibility? That seems really high.
So
From the Apple side?
Well, like you said, total.
So our sources are through Apple and other major CDNs like Akamai.
So you were okay.
Well, yeah, that was my stat you're using. So
Yes.
to clarify it, it's 96% of Apple ecosystem devices as of January in 2019 supported HLS with CMAF segments. That's with the Apple ecosystem. The trouble comes in non-Apple devices, so older set-top boxes, media players, field devices that use HLS TS and don't get updated. Those you're still going to have to synthesize HLS TS segments for, as long as they're part of your target device reach.
Android would have long tail support as well, even if you go to HLS, but that's because it's just manifest parsing, and they've been supporting essentially fragmented MP4 since Android 4-ish.
Okay, so browsers, all the current browsers will support it now. And then the mobile you're talking about, and then set-top boxes and OTT
Yeah.
boxes will be the hard ones. Because
Those depend on whether or not they're only supporting TS, at least at their primarily route and decode right now, and also other challenges for ones that aren't supporting external non-lux audio is where some of our customers we've got some challenges is that with if they have players that don't support non-lux audio, it's going to be a harder lift to get there for that, depending if they're just very old legacy players.
Good, thank you.
Any other questions? No? Oh, yes.
So, I mean, it sounds like once Edge and Firefox support CDCS,
Mhm.
then this is it, right? This is the unified DRM solution as well.
Yes. Yes.
But
It's-
only for new devices. You still got all
Yeah,
devices
so-
that don't get their play ready or Wi-Fi installation updated, and they won't support.
Yeah, so current versions of Edge, IE, will not be able to utilize unified segments yet.
And Android 7.0.
Yeah, and if you have to support older versions of Android, for sure. All right. Thank you, everyone, for joining.